Problem 2 says, consider the Boolean function f presented with the following truth table. Oh boy. Okay, I'll write out the truth table really quickly. It goes x, y, z, f. It's going to be a little bit ugly just so I can save some time. Okay, and then the outputs are 1, 0, 0, 0, 1, 0, 1, 0. And it says, write a Boolean expression using dot for and. Okay, dot equals and. I think plus equals or, right? Plus for or and prime for not. To represent f using the variables x, y, and z, justify its correctness. Okay, so this is pretty easy, right? This is using the sum of products algorithm. I'm just going to go through, pick out the places where there's a 1, and I'm going to OR those together. So I can get this truth table, or this sort of function, by saying, well, if the inputs are this, the output's 1. If the inputs are this, the output's 1. If the inputs are this, the output's 1. And else the output's 0. Basically is what I'm doing with sum of products. There might be a simpler way to write it, but this is just the easiest for me mentally to kind of go through. So I can write something like not x and not y and not z plus the next row is x and not y and not z. So x and not y and not z plus, then the last one is x and y but not z. X and y and not z. So here's a completely fine Boolean expression to represent this. I would justify using sum of products. It looks to me like it can potentially be simplified because all of these have not z, so maybe I'd write something like not z and, or let's see, not z and my two options, or my three options are x and y naught, x and y, or x and y naught. Or x naught and y naught, x and y naught, x and y. So I can do not z and x naught and y naught, oops. And I can OR that with x and y naught or x and y. Just to make sure I'm doing this correctly, this takes into account if OR only takes 2 inputs. I don't know if it specifies here, but here my OR only has 2 inputs. Here this OR has this as 1 input, and this is the other input. And then this AND has this as 1 input, and this is the other input. And this is also a fine way to write it. I'm sure there are probably more concise ones, but this works, so I'm just going to go with it. Move out of the way, make sure you can see everything. See if there are any other questions related to this. Okay, so 2b is unrelated, so I'm going to erase this. Okay. Give a Boolean expression corresponding to each of the following statements involving the Boolean variables p, q, and r. You need not justify correctness. Okay, let's just write these out. There's I least one of p, q, and r is 1. Okay, so I think I'd probably do this. Again, I could do this with sum of products, right? I could write out every single possible combination where at least one of these is 1 and OR them together. That would be fine. An easier way is probably to say something like P or R, or it's P or Q or R. I think this works because it says either P, or it's not an exclusive OR, but P can be true and these don't have to be true, Q can be true and these don't have to be true, R can be true and these don't have to be true. Any of these alone is sufficient to make this expression true, but it's not true if none of them are true. So I think this works. II says at most one of PQR is 1. At most one of PQR is 1. All right, how would we do this? Basically, it's saying that you can't have 2 of them or 3 of them be 1. At most, one of them is 1. So I guess there are only really 4 cases here. I'll just write them out because that's the easiest thing for me to do in time pressure situation like a test. The 4 cases are all of them knotted, so not P and not Q and not R. Then I can have each of them be a 1 and have the others be zeros. So I can say not P and not Q, but yes R, plus not P and Q and not R, plus P and not Q and not R. This is where Q is true, this is where R is true, this is where P is true, this is where none of them are true, and no other cases are allowed. So this should cover where at most one of these is 1. Okay. Let's go on to 3. I'll try to just put it lower. R is 1 if P and Q are both 0. So R is 1 if P and Q are 0. And then R is 0 otherwise. Okay, interesting. So P and Q are both 0 is the opposite of P or Q. So I can say down here, R is 0, not R, and P or Q. This handles R is 0 otherwise. And then I need R is 1 if P and Q are both 0. So then I say and, I'm going to erase this just because it's in the way. And R is 1, so R and not P and not Q. Okay, so here I'm saying R is 0 if either P or Q are 1, and R is 1 if they're both 0. Okay, I'll move out of the way, make sure you can see those 3. I'm going to erase them and move on to the last 2. I think they're the last 2. Okay, so 4 says P, Q, and R all have the same value. Oh, handwriting is degrading by the minute. Okay, so this is true when they're all 1 or all 0. Those are the only possible cases, so I'll just say P and Q and R, or not P and not Q and not R. And that seems pretty simple. Then exactly 2, so this is for now 5. Exactly 2 of P, Q, and R are 0. Okay. So there are, I think, 3 ways that this can be done. P and Q can be 0, Q and R can be 0, or P and R can be 0. So I'll just write out those 3 cases. I can write P and, not P and not Q and R, or not P and Q and not R, or P and not Q and not R. I think that covers those 3 cases. Might be a better way to write this. But that's okay. I've handled my 3 cases, doesn't matter. Make sure you can see it. Again, if I'm making errors, please let me know in the comments so that other people don't see this and get confused and end up more lost than they started. And I'll make sure to add a note or something